Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's video, we will again focus on the heat transfer operations, and in this regard, we are bringing the lecture number 12 for our valuable viewers. In the lecture number 11, we have shifted our focus to heat exchangers, and in the previous lecture, we have studied about the double pipe heat exchanger. We have studied the double pipe heat exchanger construction, working, applications in detail. In our today's video, we will again select another type of heat exchanger, that is the compact heat exchanger, and we will first see what are the compact heat exchangers, what are the industrial applications of compact heat exchangers, and what are the different flow patterns that are considered once we talk about the compact heat exchangers. So our today's lecture is pretty much focused on compact heat exchangers. So before starting the original lecture, if you have not subscribed to the channel yet, please subscribe to the channel. Click on the bell icon to get all updates related to this channel. So starting with the compact heat exchanger, what are these, or what are the importance of these heat exchangers? That these heat exchangers, the compact heat exchangers, are specifically designed to realize a large heat transfer area per unit volume. So this is the main application, one of the main applications, that these heat exchangers are required for large heat transfer surface area. The ratio of heat transfer surface area of a heat exchanger to its volume, as we have said now that it is for large heat transfer surface area per unit volume. So the ratio of the area to the volume is called area density, which is represented by beta. If a heat exchanger has the value of beta greater than 700 square meter per cubic meter or 200 square feet per cubic feet, then that heat exchanger is called as being compact. So this is the main classification or main thing to describe the heat exchanger as compact. If the value of beta, which is the ratio of heat transfer surface area of an exchanger to its volume, is greater than 700 square meter per cubic meter or 200 square feet per cubic feet. So this is the major introduction or the definition of compact heat exchanger. The examples of compact heat exchangers from the daily life, which include car radiators whose beta value are less than 1000 but obviously greater than 700 square meter per cubic meter. Glass ceramic gas turbine heat exchangers, the beta value is less than 6000 square meter per cubic meter. The regenerator of a Stirling engine, the value is 15,000 square meter per cubic meter approximately. And more importantly, the human lung, which is 20,000 square meter per cubic meter beta value. So these are the industrial applications like the regenerator of a Stirling engine, the gas turbine, heat exchanger, the car radiators, and more importantly, the human lung. The flow passages in these heat exchangers are very small, as it shows or it states its name as the compact heat exchanger. So the value or the flow pattern or the flow passage or the flow amount through these heat exchangers is very small, and thus this flow can be termed as the laminar flow. Obviously, once we talk about the calculations of flow rates, we consider the flow in most of the cases to be turbulent, but in these heat exchangers, because of the small value of flow rate, we call these heat exchangers flow as, or the flow through heat exchangers as laminar. These heat exchangers enable us to achieve high heat transfer area between the two fluids in a small volume, and they are commonly used in applications with strict limitations on the weight and volume of heat exchanger. So as we have initially called that these enable us to realize the high heat transfer area per unit volume. So this is the main application, and the flow rate or the flow pattern is considered to be the laminar in it. And we have seen the industrial applications and the daily life application in it. So this is the overall introduction of the compact heat exchangers. Now, once we talk about the flow pattern in compact heat exchanger, the fluids usually move perpendicular to each other. As you can see here, that this is the flow of one fluid, and this is the flow of other fluids. So these two fluids are basically move in a direction that they cross each other. So that's why we call this configuration as cross flow. We have studied two different configurations in our previous lecture. One was the co-current that both move in the same direction, and the other one was the countercurrent that if the hot fluid is moving in this direction, the cold fluid is moving in this direction. However, in cross flow, it is basically a pattern of crossing each other. Obviously, this is not physical crossing, or basically both of the fluids are at different zones, like one of them is in the outside of the tube and the other fluid is in the inside of the tube. But the pattern or the realization is that both of them are crossing each other. Now, these are basically classified as the unmixed and mixed flow. As you can see here, that both fluid unmixed, one fluid mixed, and one fluid unmixed. So let's move to our next slide and see what are the difference between these two patterns. Now the cross flow is said to be unmixed since the plate fins force the fluid to flow through a particular interfin spacing and prevent it from moving in the transverse direction, which is the parallel to the tubes. So this is the first definition of the unmixed flow, that the fluid is flowing through a particular space and there is no movement parallel to the tubes. However, the cross flow is said to be the mixed once the fluid is free to move in any direction in the transverse direction, which is parallel to the tubes as well. Like if we talk about the car radiator, both fluids are unmixed in car radiator. The presence of mixing in the fluid can have a significant effect on heat transfer characteristics of the heat exchanger, which we will be studying definitely in our upcoming parts. So this is the overall introduction about the compact heat exchanger, their industrial applications, and their relevant flow patterns. So I hope you have understood all the aspects of this lecture. If you have any queries, feedback, suggestion, please provide it in the comment box, and I would be happy to answer it. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video, and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.